In this microcontroller labs video, we are now going to look at how the Arduino or other microcontroller can manage to read a temperature from our surrounding. And with this, we should be able to read the temperature from what is called a sensor. And we will use the LM35 sensor, and the display of this particular temperature reading will be shown on the serial monitor. Now let us connect our circuit diagram. We have the Arduino Uno, and we have to check the LM35 sensor. So we can now be able to select our LM35 sensor, and we can do the connection. Now we have the sensor, and we are now trying to connect this particular LM35 sensor to a power supply. And we can give the 5 volts as a power supply, and we connect the ground. Now the sensor circuit is complete, and we will connect the analog pins of this temperature sensor to the analog to digital read pin of the Arduino Uno. And this circuit is complete, where the reading of the temperature will come from the LM35 sensor, and it will pass this temperature reading in terms of analog signal to the microcontroller, and this microcontroller will be able to read the data from the sensor and convert it into temperature degrees and must be displayed on the serial monitor. Now let us program our microcontroller chip. And you can now open your Arduino IDE, and you can start to program. Now, as I have mentioned, to enable the serial monitor to display our sensor reading from this particular Arduino Uno microcontroller, we have to start it with a serial.begin. And we can give a specific baud rate such as 9600, and in this particular section, we now enable the serial monitor to operate. And once it is done, you can go to the void loop, and we can start to initialize and fully program this microcontroller. And we can begin by initializing the integer such as the reading. And this reading is a variable that will store the analog reading from the LM35 sensor. And we can say analog read, and we specify the pin where the sensor is connected to. So we have the A0. Now we are to program the voltage reading, and in that case we define the voltage as a floating point because it will contain some decimal value. Now we can say float, let's say the voltage, and we are creating a variable voltage to specifically hold the voltage reading. And this voltage reading is in terms of the voltage value, and in that case we can see that we will accept the reading from the analog read, and we perform a conversion, and this conversion will be 5 divided by 1023.0, where the 1023 is nothing but the resolution of the analog to digital converter, because the microcontroller is a digital circuit, and to process the data it must be converted to a digital value. And in that case, with the resolution of 1023, which represent the 10-bit resolution of this particular microcontroller, we should be able to get the voltage reading. And in that case, we normally convert the analog reading into a voltage reading. So we can say we convert to the voltage, where we convert the reading and we have the 5 volts, which is the power supply that is connected to this particular LM35 sensor divided by the resolution of the analog to digital converter. Now we can create another variable such as the float, and we give this variable name temp-C. That means this temp-C represents the temperature in degrees Celsius. So the analog value that is in terms of the voltage, when we convert the analog reading into a voltage, now we are mapping the voltage with the temperature, and we can say that the temperature and the voltage, they are linearly proportional. Now we can see that the temperature C, which is equals to voltage multiplied by 100. And what does that mean? So we can be able to understand that the LM35, which will output the 10 millivolts per, let's say, degree Celsius. Now, because we now have to map the voltage with the per degree Celsius, and from this particular LM35 sensor, for every 10 millivolts, it is equivalent to 1 degree Celsius. So this is the conversion which is linearly corresponding to the temperature and the voltage, because when the analog value of the voltage, when we compare and store it in the variable voltage, now this particular voltage will now have a relationship between the degree Celsius temperature. That means that for every 10 millivolts, it will be equivalent to 1 degree Celsius. When we have the voltage reading, which is 20 millivolts, now it will be corresponding to 2 degrees Celsius, and so on. Therefore, we have this temperature C, which is a floating value because it will have a decimal point in terms of the reading. And now, since we successfully converted the voltage reading corresponding to the temperature and the voltage, we are now going to display this information to the serial monitor. And to display this reading, we now have to print some string. And let's say serial print, and we're asking the monitor to print the string such as the temperature, and the serial monitor will print the string temperature for us. And now we want to print this particular variable, which is the temp-C, where it will now be able to print the temperature in degrees Celsius. So we can also write serial print. We are now commanding the serial monitor to print our temperature, which is the temp-C. And after this, we want the serial monitor to print degree Celsius for us. And we can simply write serial dot print and then ln. And ln means a new line. So after all this information is printed, and in the next loop, it must be printed on a new line. So in that case, we normally say print ln. And now we can give space and we can have degree Celsius. And now we can add a small delay of, let's say, 1000 milliseconds for the data to be printed on the serial monitor. And once you are done with this code, you can now compile to see if there are some errors. So it is successfully compiled, so we know that we now can be able to read the temperature from the LM35 temperature sensor. So as I have mentioned earlier, we are creating a variable reading which will store only the analog value. And since it is 1023, which comprises of a 10-bit resolution, now we are mapping the reading of 1023 with respect to the voltage. And you can see from this reading, when we have the maximum values of the analog input to this particular microcontroller, this reading will be 1023. So 1023 divided by 1023 will give us 5 volts. And this is now having the maximum voltage from this LM35 sensor, which is now corresponding to the maximum temperature of the LM35. And this LM35 will also have the maximum temperature in which it can reach. And we all know that when the temperature increases, we will have the analog reading, which will also increases from 0 to 1023. And when it reaches the maximum temperature of this particular LM35, this reading will be 1023. And now it is corresponding to the 5 volts. And we are now converting this voltage reading, which is stored in the variable voltage, with respect to the millivolts, which compare the temperature linearly with the voltage. And it is linearly against the voltage by the 10 millivolts. And this is our temperature sensor reading in degrees Celsius. Now we are just giving the command for the serial monitor to just simply print our temperature reading. And now, as we have mentioned previously, in order to pass this signal using the serial monitor, we have to connect the COM port, and the COM port is known as the COM pin. So we can click the COM pin and we can simply connect the receiver to the receiver and the transmitter to transmitter. That means transmitter of this Arduino to the transmitter of the COM pin, and the receiver of the COM pin to the receiver of this particular Arduino. And now data can be transmitted through this port. And once you are done with this connection, we can now configure the port. So you can double click on the COM pin and you can, let's select, for example, COM port 3. And we click OK with the baud rate 9600, and you go to tools. Let's select the COM3 will be from the Arduino, and we can say COM4 is the port from our computer. So this will be able to receive the data coming from the Arduino. Now once this is done, we can go ahead and start the simulation. And you can run the simulation by clicking the play button, and you can click the serial monitor. And now you can be able to see that our temperature reading is around 29.33. And if we start to increase, we can also be able to see that when we decrease to 24, we'll also decrease to 24. And when we start to increase, let's say 29, 30, 31, 32, 33, we can see the latest reading. It is updated. So we have around 35 on the LM35 sensor. So we have 35.19 degrees Celsius on our serial monitor. And this is how you can be able to measure a sensor reading and display this sensor reading on a serial monitor. If you have other devices for display such as the LCD, OLED, or other display graphical user interface, you can be able to show this data in a live view mode. And I believe with the understanding of how we configure the temperature reading from a temperature sensor and we convert it into a voltage range, and it is passed through the analog pins of the microcontroller, and this microcontroller will convert this particular analog reading into a voltage range. And finally we map the voltage range with respect to the temperature, which is in degrees Celsius. And you can also apply this project into many other projects which requires the use of a temperature sensor. Later on in our future project, we can integrate the temperature sensor and we can integrate with the LCD and other relay control, for example, controlling the heating and the cooling of a particular system. So according to some reference value from the LM35 sensor, we can be able to control those devices. And this is a project which is part of the embedded system. And you can also share the video of our link to your friends so that they can also be able to learn the importance of a microcontroller and how the simulation can also be applicable to a real life application.
Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.